This lecture is being brought to you in part by the generous gifts of these sponsors.
Okay, so I'm going to be talking about something called IoT for the next hour or so. This is an evening lecture, so it's going to be non-technical. If you have any technical questions, feel free to ask me towards the end of the talk, and I'll do my best to answer them, or you can always reach out to me offline. So before talking about IoT, I thought it would be useful to spend just a couple of minutes talking about the origin of the internet itself. So, because IoT builds on what the internet provides to you. And many of you may know the story behind the internet. It was a project that was sponsored by the ARPA, Advanced Research Projects Agency, way back in the 70s, 60s actually. And the idea was to create a network that would not be disruptible by an enemy, right? So they came up with this notion of what is called a packet switch network. And the idea was to not have any single point of failure, unlike a telephone exchange where all your lines go through a single point, and then if the enemy takes that out, then you're dead in the water. So they came up with a mechanism whereby you could have multiple nodes, and this left diagram shows the first 4 nodes that are part of the internet. Then the diagram to the right shows, I think, the first 11 nodes that are part of the internet that was stood up. And the core idea was this notion of packet switching, where if node A wants to send some message to node F, it can go through any route that's available, and if one of the nodes gets taken out, then it finds another route, much like your interstate highway system, where if one road is blocked, you might find, Google Maps will reroute you to another path to get to your destination. So there are a lot of interesting ideas that were proposed during this time. In fact, one of the interesting things is you read some of these early papers, and you think, oh, we just invented something cool recently, and you read these papers and you find out, yeah, they already thought about this 40 years ago. Maybe the technology didn't exist to do this, but in reality, the ideas already existed even way back then. So from the original beginnings of the packet switch network, the first significant development was something called TCP/IP, and that may not mean anything to you, or it may mean something to you, but it basically allowed you to create a unique address for every computer that was connected to the internet. And some of you may have a home computer and you pull up this configuration and it says, oh, your IP address is 192.168.something.something. Well, that's a unique address that's designed and assigned to your computer. So they came up with this notion of uniquely addressing every computer that would be connected to the internet. And basically, it's like a postal address, right? So you can then send a message from any computer in the internet to any other computer. And this was all at times when nobody was really using the internet except academics. So keep that in mind. And then the initial applications that were built at that time were all these command line things, which nobody uses now. And when my wife sees me using this, she thinks I'm in the Matrix or something. But anyway. And there were things like Telnet, where you would remotely connect to a computer, transfer a file, send an email. No nice web interface at that time. And they had this thing called Usenet News that would exchange news articles and would operate over dial-up modems. And things still worked, but they were very slow. And only people who are really geeky would care to use these kinds of technologies. And then everything changed when the World Wide Web was created, right? So this happened in 1989. Tim Berners-Lee came up with this notion of coming up a language called HTML that you can use to mark up pages very simply, and this protocol called HTTP. And now all of a sudden you have a graphical interface. People could create nice documents and you can go look for them. And then there were search engines that you could go to and find information out there. Yahoo was one of the first one, and now of course we have Google and Bing. And all of a sudden this made the internet accessible to everybody, right? So this made it much more popular. So now you have basically a planet-wide network that connects pretty much every device together, and you can run any kind of application you want to on it. Of course, we have email, we have web browsing, we have video streaming, which actually uses up almost all of the bandwidth of the internet, video conferencing, online shopping, and so on. So anybody can write any kind of application that requires some kind of communication in the back end, and it can be deployed on the internet. So that's so much about the internet. But what about IoT, or the Internet of Things? So initially, what was connected to the internet were basically workstations. There were terminals that people would sit in front of and work and talk to other terminals that other people were sitting in front of, or maybe mainframes in the back end that would do some computation when you submitted a task, and they would go off and do it and produce a result. So this changed when the first device, and this was at CMU, it was a Coca-Cola vending machine, was connected to the internet, and it was the first instance of an appliance, i.e. something that was not a terminal or a computer that somebody sat down to use, was connected to the internet. And of course, the idea for doing this was that some student wanted to find out whether the Coke machine had Coke in it, so that they didn't have to get up out of their desk, walk to the machine, and see if it had any sodas in it, right? So maybe it's true that laziness is the mother of all invention. So this was the very first time that somebody took a device, not a computer, and said, I would like to connect this to a network so I can do something with it. I can find out, if it has any sodas in the machine, when was it last refilled, what was the temperature of the sodas in the machine, and then decide whether they want to get up from their chair, go to the machine, and get themselves a soda, right? So that was the first example. And this machine, I believe, is still in the museum at CMU. And that was in 1982. But one of the first interesting concepts that was developed happened in 1988 by a researcher named Mark Weiser. He was working at that time for Xerox PARC, the Palo Alto Research Center. And he coined this term ubiquitous computing, and this was in 1988, sorry. And the key idea here was that computers should not be things that you sit in front of and use actively, but they should be something that's invisible. And the whole goal for this computer is to make your life better or to make your life easier, right? So this is the principle of ubiquitous computing. So put computers all around you. You shouldn't have to see them. You shouldn't even know they exist. You shouldn't have to interact with them, but they should somehow make your life easier, right? So that was kind of the one of the initial thoughts behind this whole notion of Internet of Things. And the term IoT itself was coined by this researcher, Kevin Ashton, who was actually at Procter & Gamble. And he was working on something called RFID, or radio frequency identification, right? So RFID is this little tag that gets put on almost everything now. And basically there are scanners that can automatically scan these RFID tags. And then things like, well, how much soup do I have on the shelf, right? And if it's getting low on soup, the system can go ahead and order more. And you can also track these things using logistics, right? You can say, oh, this container ship got loaded with all of this stuff. It's here, it's going to get to this port at this time. Oh, it's going to get on this UPS truck at this time. So everything is tracked using this RFID mechanism. And that was done by Kevin Ashton at Procter & Gamble. And he actually coined the term Internet of Things just because he thought, oh, the internet is popular. How can I come up with something that connects to the internet so that what I'm coming up with is also popular, right? So he actually coined the term IoT. And RFID, you can say, is something that's part of IoT, but it's not really a compute device. It's just a passive tag that something else scans and then provides information about that. But RFID is now ubiquitous. So not to use the word ubiquitous again, but if you have flown recently on an airline, you have your app, like a Delta app or whatever. It'll tell you, oh, your baggage is now arriving at this carousel. How does it know that? Because your luggage tag that they put on you or on the bag has an RFID in it, and everything gets scanned as it's going through the luggage system. And when it's being put onto the belt, there's a scanner there that says, oh, this bag is coming out. And by the way, this bag belongs to this person. Let me send a message to this person saying, your bag is now arriving, right? So RFID enables all kinds of automation to take place in the background, and it's very useful. So what is the Internet of Things? And the basic idea here is to take everyday objects, could be a chair, could be a light, could be that projector, could be a poster, whatever it might be. Take everyday objects and basically make them into a small computer that connects to the network, right? So these things can be sensors. So for example, there could be a weight sensor in this platform that's measuring how much I weigh. It could be an actuator, so it could be a switch that you can remotely turn on and off. But the key idea is that they are connected to a network so I can talk to them over this network. And the fundamental assumption is that somehow connecting all of these things together that can talk to the network will create something that is useful, create a smart thing, a smart device, a smart home, a smart environment, right? And that's the hypothesis, and you can decide whether it works for you and it is proven or it is not proven. But it is also true that IoT is pretty much everywhere at this point, right? So how many of you have a Fitbit? Probably a fair number, or a smartwatch. Well, that's an example of an IoT device, and it's basically doing health monitoring of some sort. It's counting the number of steps you take, it's measuring your heart rate. Some of them are pretty advanced, they measure all kinds of things. But that's an example of an IoT device that has become ubiquitous, and a lot of people have it, right? Likewise, smart switches. You might have smart switches in your home. where things maybe you can automatically turn them on or off using something like Alexa, and then that's an example of an IoT device. And likewise, you can have smart outlets that turn appliances on or off. You can have appliances that report how much current they're consuming, or you can have appliances that automatically balance out when one appliance turns on, another one turns on and turns off, so that you can balance how much current you're using in your home, right? So these are all examples of devices connected to a network that, by exchanging information with each other, can provide some useful capability. Now, this also extends beyond your home environment. A lot of people are working on what we call smart cities for doing things like parking services. Pensacola Airport doesn't quite have this yet, but a lot of airports, you drive into the parking garage, it tells you which floor has how many spots available, and as you're driving through, it says, if you go this way, there are 5 spots available, if you go this way, there are 10, and that's because every parking spot has a sensor that's detecting whether there's a car or vehicle parked there or not, and all of that information is collaborated, and then you know whether there is a spot available on that floor and which direction the spot happens to be in, right? But this also happens now in cities, so you can get apps in some cities where it'll tell you where parking is available. If you're going to an event, for example, and you expect parking to be crowded, you can even reserve a spot ahead of time and make sure that that spot's available for you when you get there. So there's a lot of work being done to make it convenient, if you will, for finding parking. But also traffic control, right? So looking at information flow between vehicles and looking at what vehicles are going where and trying to control traffic. That's another example of what smart cities are trying to do, providing information about public transportation. So a lot of cities now have, if they have a bus system or a train system, they also have an app, and you can go to the app and it'll tell you exactly when the bus is going to arrive, where is the next train, where is it going, is there a delay. All of these capabilities are made possible using IoT. Then there are other things like air quality sensors, which are also quite common. And I'll give you an example of this a little later, but these can measure things like how many particles are there in the atmosphere or in the air, what is the radiation, what's the UV radiation, what's the temperature, humidity outside, how much noise pollution is there. In fact, the city of Chicago, for example, has installed something called, there's a citywide system, and what it does is to measure things like pollution, air quality, noise pollution, radiation throughout the city. And all of this information is available for free. So you can go access this information and find out, where is it safe to go outside. In fact, on your phone now, you typically get reports saying, oh, the radiation level outside is so-and-so, or the pollution level is so-and-so. You can go running today because the weather quality is, air quality is good, right? Examples of IoT. So they call it the city of things. Then there's the smart power grids that are looking at how to better balance energy utilization across the electrical power grid, if you will. So that's another example where IoT can help, where you can measuring consumption of power, trying to learn patterns of power consumption over time, trying to predict what kind of power consumption might be in the future, and then planning for that and balancing out the load. And then I'll talk a little bit more about this, but smart cars are coming online very soon. So cars that talk to each other, that exchange information, that talk to the intersection to know more about when the red light is going to turn green. So these are all examples of IoT. This is a diagram that I don't expect any of you to read, but it's an interesting diagram, and it was done by this organization called Beecham Research, and they basically looked at all the different domains. So if you look at the bottom, there's building and construction, energy, consumer and home, health and life sciences, industrial, transport and logistics, retail, security and public safety, and communications and information technology. And these are all domains where they've identified specific use cases where IoT can play a role and help solve a specific problem. So you can see it's a very broad scope in terms of how IoT can be applied. Now, we can look at something called the growth of connected devices on the network. And actually, this is an old diagram from Cisco, and this claims that by 2020, which is already passed, it predicted that we would have 50 billion devices connected to the internet. That prediction actually has not happened. But before I move to the more accurate numbers, I do want to point out something. So if you notice, up to about 2011 or so, towards the left side of it, the number of devices connected to the internet was 0.5 billion. Then, the laptop or the personal computer became really popular, and you can see there's a kind of a linear growth there up till about 2014 or so, and then IoT starts getting deployed, and you can see that the growth starts becoming exponential, right? So, in fact, if you look at the number of devices that are connected to the internet, the black numbers here are things like personal computers, right, that people use. The blue bars are IoT devices that people don't necessarily directly use, but they're connected to the network and they provide some function. And you can see that the growth is significantly higher with IoT devices compared to just regular personal computers. And in fact, this trend is expected to continue, and pretty soon, you will have a lot more IoT devices connected to the network than like computers or cell phones. So I do want to touch on a few what I would call important historical developments that have brought us here in terms of IoT, and I'll just briefly talk about these. So on the left, you see something called the Raspberry Pi, and some of you may have heard of this thing. It's a credit card-sized computer, right? But it was one of the first computers ever made with a price point of about $35, right? So you start putting out a full-fledged computer that's about the size of a credit card for $35. That makes it a lot more accessible. So a lot of people started buying these things and playing with them, right? Because $35, you can go buy it, you give it to your kids. It doesn't matter if they break it, but maybe they'll learn something from it, or maybe you will learn something from it. You create something, and this is a way of exploration, and it enables a lot more people to start exploring things than just those with computers in a laboratory setting, if you will. Likewise, in the middle, you see something called the Arduino. This was another great platform that was put out that allowed a lot of people to start experimenting with connecting computers to things in the world, to connecting to sensors, connecting to actuators, turning on motors, or detecting how much light there is in this room, whatever it might be, right? So basically, it was only limited by your imagination. Cost was no longer a barrier for you to get these things and start playing with them. Another really important development for IoT was wireless communication, because, if you have to always plug into the wall and you always have to be connected to a network cable, it's not as practical, right? But if you start having wireless communication, then you can have devices anywhere. You don't need to deploy a lot of infrastructure, and they can start talking and communicating with each other. As a funny story, at the bottom here, I have a very old, one of the very first Wi-Fi cards that were made for laptops, right? So it's called a WaveLAN, made at that time by a company called Lucent Technologies, which doesn't exist anymore. And I have a picture of this because it's kind of funny that in 1994, I set up the first Wi-Fi network at the University of West Florida using 2 of these cards. And the whole idea was that I could sit in the conference room with my laptop, no wires, and have connectivity to the internet, right? So that was a major accomplishment at that time. So now it's like, what are you talking about? Right. On the right, bottom right, you also see another computer board, and this is also an IoT board, and this is using a communication protocol called LoRa, L-O-R-A. This was another really interesting development that enabled IoT, because LoRa provides long-range communications, and this enabled things like water meters, electricity meters, and all of these things to start getting put on the internet, because you don't have to have a Wi-Fi router. You can just talk to some infrastructure that's several kilometers away, and there was no problem. And it was very low power, so it could run off a couple of AA batteries for like several months. And that was key, because if you have to go change the battery every day, you're not going to use it, right? So that was also important. So now we have many examples of IoT in our environment. Probably a lot of you have an Amazon Echo device. That's an example of an IoT device. I mentioned Fitbits already, but smartwatches in general. Probably many of you have things like Ring doorbells. I know our neighborhood has lots of Ring doorbells. They're all examples of IoT devices. Smart thermostats, and Nest was one of the first, but there are now several of them. Examples of IoT devices, but also things like the Philips Hue, which is a smart bulb, allows you to remotely connect to it, change its intensity, change its color. Yes, so we like to play with these kinds of things. Things like a remote operator or autonomous vacuum cleaner, right? The Roomba is another example. And then you start having these ecosystems, like Samsung now has refrigerators, clocks, all kinds of things, dishwashers that talk to your network and have become IoT devices. And this leads us to several cartoons like this one about appliances talking to each other behind your back, complaining about you and how you use them, right? Or about the refrigerator reminding you that you were supposed to bring milk and you did not bring it, right? And these are cartoons, but these can actually happen. So you can certainly have RFID tags on all your produce, and your refrigerator can track when you put them in and when you take them out. It can measure how at what rate you use them. And yes, it can remind you when you're running low on milk, and you should pay attention to that and maybe get it. I don't know. Or you can simply delegate it to talk to Amazon and order what you're missing to begin with. So, all right. So here are some other examples of IoT devices. These may not be ones that you directly interact with or use, but a lot of electricity meters now, nobody comes around to read them because they're all wirelessly communicating how much power you use, and so that saves on a technician coming out to read the meter. Water meters, again, nobody comes out to read those anymore. If you have a water meter, you might notice a small plastic patch on top of the water meter, which is actually an antenna that is sending the information about your consumption to the utility provider. We talked about parking spot meters. Then we also have things like air quality sensors, which are becoming quite popular, maybe more in Europe than here. So there's a platform called Airly, and I think that's a picture of that on the top in the middle there. And on the right is, for example, a map of, this is in the city of Warsaw in Poland, and you can go in there and you can see all the Airly devices that have been deployed in the city. You can click on any one of them, you can find out what the pollution is, you can find out what the temperature is, what the humidity is, and you can track these trends over time, right? And these are devices actually purchased by individuals. They just install them in their homes or outside in their balconies, and the system communicates with the Airly platform, makes this information available, and the whole idea is to make it a crowdsourcing environment, right? So you provide some information about your environment, but in return you can get information about other people and what they're providing as well, right? So putting all of these devices together makes it quite powerful. Likewise, in Europe, there's another project called ElectroSense. I don't have a picture of that here. And their goal is to monitor RF signals. So look for rogue Wi-Fi providers, look for illegal transmissions, try and localize them and pinpoint them, because they look at the radio frequency spectrum as a protected resource, and they want to make sure that if somebody's abusing it, they can actually find that out and then figure out who's doing that. Now, there are clearly some examples of things that maybe you don't need to connect to the internet. So here's an example of apparently a wirelessly controlled perfume dispenser that you can have in your house, just so that you can get on your smartphone and tell it to dispense some pleasant aromas if you don't like it. So do I really need to have that? I'm not so sure. Here's another example, a smart toilet seat. And apparently this toilet seat will measure your blood pressure, it'll measure your weight, your pulse, and your oxygen levels every day when you use it. And you might laugh at this, but actually it is increasingly turning out that more and more people are building devices that will instrument your toilet, unfortunately. Because you can learn a lot about your health, apparently, from your bodily outputs. So there are lots of devices being brought to market that will actually provide this information. It'll analyze your poop, it'll analyze your pee, it'll tell you if you're dehydrated, it'll tell you if you have high blood sugars, all kinds of things. And there are lots of people who have gotten patents on this and who have gotten funding to build these products, so you'll start seeing these more and more come out commercially. And yes, I think they will provide some good. So here's an example of a project that we at IHMC actually wanted to work on in conjunction with the University of West Florida. And the idea here was to use IoT to essentially instrument smart homes or assisted living environments or other communities where elderly people live, in order to be able to monitor their activities over time. Unfortunately, we didn't get funding for this project back then, but we're always looking. So if anybody's interested, come talk to us later. But the idea here was to basically instrument your living environment with a variety of sensors and to be able to monitor these and then observe patterns over time. So for example, if I turn that stove on in the morning and forget to turn it off a half an hour later, maybe that should be something that somebody needs to be reminded about, right? Because maybe I'm getting forgetful. Maybe if usually I always get up at 9 a.m. and have coffee, and today it's 11 a.m. and the coffee maker has not been turned on, maybe that's a cause for alarm, right? So that should be something that you could raise an alert. Your speech, the way you talk, for example, reveals a lot about you. So if you have algorithms that are looking at your speech patterns over time and learn what you say, how you say, your intonation, and so on, and if you detect a change in that, that could be an example of something that needs to be looked into, right? So these are all situations where IoT and the installation of these kinds of monitoring capabilities in your homes could really help monitor and care for individuals, especially as they age. So now, some of this, since the time we wrote that proposal, some of this has already happened. So Amazon, for example, has something called Alexa Together, and this is a subscription service that you can get, and you can basically use this to keep an eye on your parents or other elderly people, and it does a number of things. So, for example, it does customized alerts, so that if something is missing, some activity is missing, you get notified. You have things like snapshots of what activities somebody is doing. You have things like detecting falls by people, and they have a variety of fall sensors that you can tie into Alexa. So the one on the left is a camera-based thing that looks at visually if somebody has fallen. The one in the middle is something that you wear that detects if it's fallen. The one on the right is actually a microwave-based system that also detects if there's a fall, and then notifies people about the fall. It could be either your children, or it could be a caregiver or something like that. So some of this has been done, but I think there's still a lot more interesting work to be done in this area. So talking about Amazon and Google and so on, this brings us to an interesting issue, which is what we call the ecosystem problem, right? So every one of these manufacturers are, of course, in it to make some money, right? So Amazon wants you to buy all of their products, buy their subscriptions, because that's how they make money from selling you these services. So at this point, basically, there are 4 major providers or 4 major ecosystems that are out there. So one is, of course, Amazon. The second is Google. Then you have Apple, the HomeKit system, if you will. And then you have Samsung with its SmartThings. And one of the problems is that these could go away at some point or another. And then you're left with a bunch of devices that don't work. As a simple example, when I had my house built back in 2002, I installed light switches throughout the house that use a protocol called X10. And actually, yes, I had a computer back then that I could talk to that would say, turn on this light, and it would actually send a signal and turn the light on. Nobody else had this, and everybody thought I was a geek for doing it, but now it's everywhere, right? Okay. But this X10 and the successor to that, Insteon, they have disappeared, right? So those platforms don't exist anymore. So I can no longer go to Alexa and say, turn on my kitchen lights, because the platform that Alexa used to talk to has gone out of business, and now I'm stuck with a bunch of light switches that don't work. Okay, so those are some issues that need to be worked out. So what are some enabling factors for IoT? So one big thing is cost, and this is clearly driven by volume, in the sense that the more they make, the more they sell, the more you buy, the lower the cost gets, right? And IoT has really capitalized on this notion of we're going to sell lots and lots of these at very low cost, and then that's how they make the money, but that's also how they inject their product into the environment. But another thing is miniaturization. I mean, you've all seen how small devices have gotten, everything from cell phones, which used to be like a brick, down to basically a candy bar size. You have seen how watches have gotten smaller, how Fitbits have gotten smaller. So miniaturization is very important to adoption, if you will. And battery technology is another, right? If batteries don't last for a long time, or if they're very big, they're bulky, you don't want to use them. So you have to come up with mechanisms whereby either the power consumption is reduced or the batteries get more efficient. I already talked about wireless communications a little bit. I think that's very important. But also this notion of do-it-yourself people, right? So people who just want to try something. I want to know when somebody opens my mailbox. I'm going to build a device. I'm going to use one of those Arduino or Raspberry Pis. I'm going to put a sensor in there. It's going to send me a message. And now this works. I'm going to publish this project online. Somebody else will take it, do something else with it, build upon it, and republish it, right? So this has really helped to increase the adoption of IoT and the development of IoT capabilities. And you have to couple that also with open source software. So this trend to not make commercial things, but to make software that's free, that anybody can use, download, use it, improve it, and republish it as free, has really enabled the development of IoT capabilities in general. Now, another aspect here, which is important, is what we call cloud computing. So yes, you build a system, and maybe there are 5 people using it. Now, what happens if it goes to 1 million people using it, right? So you have to be able to scale. And one of the things that has really enabled scaling is this notion of cloud computing, where you can go to things like Amazon AWS, Amazon Web Services. You can say, oh, I had 5 servers yesterday, I need 50 servers today, and they're able to provide that to you, right? So this notion of scaling almost infinitely your capacity is very important. So, all right. Now, what are some driving forces behind IoT? So one is, of course, cost cutting. And the example here is the utility meter readings, right? So if you can reduce your cost by deploying IoT, you're going to do it. And this has been a big driver for the market. Also, preventive maintenance. So I have a funny story here, but we collaborate a lot with a university in Italy called the University of Ferrara. And they work with a maker of gelato machines called Carpigiani. By the way, the best gelato machine ever. And by the way, there's now one in Pensacola that uses this machine. It's the gelato, I can't remember what it is called, but it's in the old Sacred Heart building. Yes. So they tell me they have a Carpigiani machine. So, and so this university, University of Ferrara, worked with this company, which is in their local area, to start adding IoT capabilities to monitor how well the machine is performing, because you can do preventive maintenance. You can detect the fact that something is starting to wear out, and you can then fix it before it actually breaks. I'm not saying they're extremely successful, because, by the way, apparently at least half of the gelato machines for McDonald's are made by this company, Carpigiani. And I'm told that a number of them don't work all the time. So I'm not saying the University of Ferrara capability, and there are some students here from Ferrara, so I shouldn't make fun, is in all the McDonald's machines, but I'm just saying. Okay. And then user experience and convenience. These are also big factors, right? So if it improves your experience, if it automates things that are tedious for you, you're going to want to use IoT, or if it makes something more convenient. But then there's also new capabilities that can be provided by IoT, like we talked about physiological monitoring of health parameters or assistive technologies, right? These are all things that can enable IoT adoption. Now, another aspect that I haven't touched on so far very much, but connected vehicles. This is another big part of IoT. So pretty soon, every single car and roadway and traffic light is going to be an IoT device, and they're all going to be talking to each other, and the idea is to improve the efficiency with which things operate. So traffic flow, intersections, flow of traffic through intersections. I mean, you've all been sitting at a red light with no other traffic saying, why am I waiting here, right? So certainly things can improve beyond the state of the current art, if you will. So the smart intersections is a big area of research, and it's enabled something called vehicle-to-vehicle and vehicle-to-infrastructure, V2V and V2I communications, where one vehicle can talk to the next, but also the vehicle can talk to the traffic light and other infrastructure that might be out there. Now, I'm not saying we'll get to this point, and this is a funny video clip. It's on YouTube, and I'll just let this play for a second. I should preface this by saying this is fake, right? This is fake. This doesn't actually happen. But it's entertaining nevertheless. Nobody gets hit. Nobody dies. So. And look at that bicycle. And the people running. All right. I'm not saying IoT will get us there, but I think it can get us to better than what we do now. Now, here's an example of some work that we were doing here at IHMC on this notion of connected cars. So you will see, so these are toy cars because that's what we were playing with, but adding capabilities to them. So notice that in that case, the first car went over a bump, and it communicated that information to the car behind it so that the car behind it could avoid the bump. Likewise, here's an example where a car is just sitting on the road, so the other car avoids it because it knows that there is a car sitting there because the cars are communicating with each other, right? So these are examples of things that connected cars can do. How many times have you, if you have a car with a start-stop engine, right? You stop, the engine goes off, and then when you let go of the brake, it starts again. So can't the car be a little smarter and know that when you stop at the red light, the red light is going to turn green in the next second, so you don't stop the engine. Because stopping and starting the engine is wear and tear. But IoT can enable those kinds of things, right? Likewise, if I'm in a hybrid car and I'm going uphill and the car has to detect that it has to start the gasoline engine, but the car in front of you can tell you, yeah, you're going to be going up an incline in the next 30 seconds or 15 seconds, so start your engine, right? So a lot of things can be achieved in terms of efficiencies and better user experience by having these cars communicate with each other. Okay. Oh, I think we already did this one. Okay. Now here's an interesting example that one of my colleagues gave to me, and it's an example where these researchers in a university in Sweden took a rose, a regular rose, and essentially made it a bionic rose. So this is a living rose, right? And they were able to replace part of the rose to become communication lines and to be able to store energy and to be able to, well, they haven't made it do anything smart yet, but they will. They're working on it. So they're working on adding circuitry to this using the biology of the rose in order to make it something that's an electronic thing that can do something. It can store energy. It can potentially communicate using some of its replaced capillary veins or whatever they call it. I don't remember exactly what they did, but they basically converted this rose into a electronic thing, right, that can do something. So that research is still ongoing. So I've talked a lot about IoT in general, but I do want to spend some time talking about IoT work that we are doing here at IHMC. And some of this started back in 2012, 2013, when I started working as part of a NATO group looking at military applications of IoT. So in particular, what we wanted to do at that time was IoT was kind of proliferating in the commercial world. And from a military perspective, we wanted to see, well, what is the effect that IoT has on the military? Is it useful? Is it bad? How can we leverage it? So that's why this working group was set up involving 10 other countries. And I co-chaired this group from the US side. And we started looking at all the different applications that IoT could play in the military domain, right? So obviously things like automated monitoring, logistics, health and wellness tracking of soldiers, smart sensing and information gathering. These are all application domains that IoT can help. There's a funny story, not funny, there's an interesting story. When I started this group, there were some people from NATO, the NATO Communications and Information Agency, who were responsible for setting up the Afghan mission network when we were in Afghanistan. So this one guy told me that the way they set this up is that they would use communication relays that consisted of radio towers on top of hills. Well, to do a communications relay, you need power. So they put generators on top of these hills. And generators need fuel to be able to run. So they had to have people go pretty much every day, leave the base, go out to the top of this hill, check to see how much fuel the generator had, and then to be able to refuel it if necessary, and then come back down. And every time they left the wire, they went outside the wire, of course, that was a threat to their life or to their health, because the adversary was also tracking when these people would leave the base and go out to check these communication towers. And that problem could have been solved with a $50 device that is looking at how much fuel there is in that generator and sending that down as a signal, so you don't have to go outside just to check the fuel level, right? So there are lots of simple things like that, but could be very meaningful things that can be done to improve the performance of these systems in the military. Logistics, why can't my gun track how many bullets I've fired and know how many bullets I have left and know how many clips I have, so that if I need more, somebody is told about it? And if the entire company is running low on ammunition, the logistics officer is already informed that we need more ammunition, right? So all of these things can be automated. Likewise, fuel, food supplies, water supplies, quality of the drinking water, right? This is another major problem when you are in the military. You have to figure out whether the water is drinkable or not, right? So these are all examples where IoT can really help. Now, there was another important question that we wanted to address as part of this group, and that was, how can the adversary use IoT against us? So one of the big challenges is that, before, only we, i.e. countries like the US and other European countries, could afford to build the types of sensors that we would deploy to give us advanced information, because they were expensive, they required a lot of specific technology, the technology was protected, and so only a few people had it. Think night vision goggles, right? But now, anybody can go to Amazon or the equivalent in China and buy things for just a few dollars and put together the same kinds of sensors that we use in our military. So the question becomes, what can the adversary do by using inexpensive IoT against us? So that was another issue that we wanted to be able to better understand. So this diagram is kind of complicated, and I won't really talk about it, but I will talk later on about one of the example applications we built in terms of humanitarian assistance and disaster response, in terms of connecting civilian information sources together in order to provide better situational awareness to a commander, for example. Now, here's an example of another problem that occurs with the military, and that's the information leakage problem. And some of you may have come across this, but a lot of soldiers typically wear Fitbit devices that track their exercise, right? And it so happened that there was a company called Strava that set up basically a social networking site. It was for runners, for people who like to run, where their information about where they were running, how much they were running, and so on got uploaded to this website. And then you could see, oh yeah, so all these people are running in this area, so maybe I want to go run over there. And the unintended consequence of this is that they could figure out random areas where you would see a lot of people running. For example, in the middle of nowhere in Africa, right? And it became pretty apparent that those were military bases, but they were not locations that were necessarily disclosed, right? So this is an example where a commercial IoT, like a Fitbit, provided information to somebody, a website, a social networking website, which then allowed other people to infer where a military base was located, right? So that was a problem that was highlighted by this researcher, Nathan Rooser, and this particular base that is shown in this diagram was already known, and he didn't really post the location of the other bases, but it was pretty evident where people were located because of this reason that they were using Fitbits. So now here's an example of something that we did as part of the NATO group, and this was going along the lines of leveraging what we call civil information, so things that you might get from commercial IoT, from smart city environments, in order to provide humanitarian assistance and disaster relief. So the idea is that, you know, if you're providing this kind of a relief, consider a smart city environment where there are lots of sensors already out there, lots of street cameras, lots of, you know, road quality sensors, air quality sensors. You know, what can we do to leverage that information? So if you're the military and you're going out to do one of these Hatter operations, then first of all, you have to understand what is the situation on the ground. And you do this by either deploying some of your sensors, talking to people, or developing other ways to get information about the situation. But if you have IoT in a city, and that IoT capability is already able to provide to you a lot of information about what's going on, it allows you to understand the situation on the ground a lot faster, right? So that was the example that we were trying to show. You know, if you're operating in a futuristic smart city environment, how can you dramatically improve your situation awareness by using these IoT capabilities? So on the top right, you see a screen. It's an application that the military uses a lot called ATAC. And in this ATAC, this is sit in Finland. So I'm down at the port in Helsinki. And my goal is to go to the embassy, pick up some people, and go to the airport so they can be evacuated. And so I planned this route, which is shown on the blue line. And then what the system will give you is all the sensors in the civilian domain that are available along your route that you can potentially use to help plan your mission. So for example, it tells you, oh, there's a street camera there. You can click on that, get a live feed, and see what the road conditions are like. There's a temperature sensor that'll tell you maybe the road is frozen or not. So all of this information is then made available, also things like blocked roads, for example. So a lot of these cities are starting to set up these services. Finland was one of the first. They set up something called the DigiTraffic API that allows anybody to go ask, oh, what are all the street cameras out there? What's the weather sensors? Get me that information. But for example, New York has this now. It's called 511ny.org. Now, a layperson can't necessarily go just access any street camera on the city of New York because there are privacy concerns. But for example, if you are part of public response or police or military, you can go get what is called an API key, and you can go get this data, and you can use that for your planning purposes, right? So a lot of cities are starting to deploy these capabilities, and our goal was to develop a service that would then leverage these capabilities and provide that information to the military operators. So likewise, at the bottom was another example in the city of Warsaw in Poland, where we did another demonstration, similar notion of evacuating somebody from where they were, going to take them to the airport. In this case, we took street cameras and then we piped it into a very simple AI algorithm called YOLO. Some of you may have heard of it, but basically it outlines things that says, oh, this is a car, this is a person, and so on. And of course, the sophisticated military versions do a lot more than that, but this is the example I'm showing on the screen. Something else that we do here at IHMC is we support the US Army in a program that they're running called the Internet of Battlefield Things, or IOBT. And this is one of those fundamental research programs looking at, you know, the role of IoT in the US Army. It's a 10-year program. I think we're now into year 6 or year 7. And it funds many universities throughout the US. And one of the interesting things that we did here was we set up something called this Distributed Virtual Proving Ground, which is actually based at IHMC. The central part is based at IHMC. And the idea there was to be able to basically connect all of these university sites together so that they could do experimentation on a continuous basis. So this is, of course, during COVID. And before COVID, what would happen? Well, we would say, oh, everybody come together this day, bring your latest algorithms, bring your latest technology. We're going to connect it all up together, see how it does. Well, COVID kind of made that not doable. So we set up this distributed virtual proving ground where these universities could be where they were, the researchers could be in their labs, but we connected all these labs together, going through IHMC at that time, and then we could do this kind of distributed experimentation. And then we found not only can we do this by not having people travel, but we can do this all the time. It can be done continuously as opposed to twice a year or 3 times a year, right? So that's still something that's ongoing. Another project that we're doing right now is for the US Air Force. It's called Kennel, and Kennel has a very long acronym that I'm not even going to try and remember. But the idea here was to use IoT, again, low-cost IoT devices, to look for chemical, biological, radiological, nuclear kinds of threats, right? So CBRNE. And so the idea was to build a network of these unattended ground sensors, or UGS as we call them, small, inexpensive devices that can be deployed in any environment that can provide this information to soldiers or airmen in this particular case. And the whole motivation for this initially was for the Air Force to protect kind of forward deployed airfields. They said, one of the use cases they came to us, they said, well, we have this air base in Alaska, and sometimes moose tend to cross the runway, and if I don't know that, I can't, I don't know when it's safe to land a plane. Well, we can deploy a sensor that tells you if there's something blocking the runway with no problem, right? So I have a short video here that's going to talk about some of the stuff that we've been building, and actually Daniel sitting over there is the one who did most of the work. So he's been building a lot of these what we call threat detection boxes that come in various shapes and sizes. There's some example devices there that show you what the respective size is, and these are some of the capabilities that we have deployed. So this is a threat detection box that's being deployed at various locations, and that'll tell you things like if somebody's moving, what's the air quality, what's the radiation level, are there any chemical agents in this area, and if so, they will notify a user. You can deploy them very flexibly on canines, on UAVs, robotic dogs, which are very popular nowadays. So here's actually a roof of our old building. So you can just go stick a sensor in there. In this particular example, the idea was that if I'm an operator, I'm going into a building, I want to know if there's somebody moving behind me. So I stick this in the doorway. Then I go in, and if there's movement behind me, I get an alert essentially. So. Of course, you can track vehicles using GPS. Okay, that's an example of a proximity sensor that looks for movement. Notice that they're all solar powered, so basically the idea is that you can leave them and they will run forever as long as they get some amount of sun during the day. And that was also very important because we couldn't have systems where you have to go change the battery every so often, because that puts them at unnecessary risk. So then we can do things like perimeter intrusion, where you get an alert on a map saying, oh, something has moved in this area. So you can imagine an airfield or some kind of a military base where you deploy these all around. Now, I should point out that, of course, these sensors exist, right? Military already has these sensors. The point is that they were pretty expensive, right? So sensors that do things like this cost usually hundreds to thousands of dollars. Here, the objective is to build something that costs $50, because then, by the way, you deploy it, it gets destroyed, it doesn't matter. You don't even have to go back and pick it up because, well, you just discard $50 and you build a new one for the next time you need to use something. So in the interest of time, I will advance a little bit here. So we've, of course, taken the system to a number of military bases where they've tried them out and given us feedback in terms of how will they work. This shows a number of CBRNE exercises. And by the way, I have to say I can never do what they do, because they wear gear and go into environments where there's things that nobody wants to be around. So I don't know how they do what they do. Okay, so I want to touch on a couple of other topics before we wrap up. So one is this notion of multi-domain operations, and some of you may have heard of this, but the idea here is to combine what was traditionally 5 separate domains: air, land, sea, space, and cyber, into one domain so that you can coordinate behaviors across these different domains. And if you've heard of the term MDO, that's what that means. So it's like I'm somebody on the ground, but I want to be able to use the resources of space or satellite. I want to use the resources of an aircraft to be able to provide something for me, or I want a cyber attack to take out my adversary's capabilities so that they cannot communicate while I do something. So these are all examples of multi-domain operations. But one of the things we have been working on recently is to add the notion of a civilian domain into multi-domain operations, and that civilian domain is represented by Internet of Things. So here's an example of a recent exercise we did as part of NATO last October. It was in Latvia, where basically they were doing a multi-domain operation. It was a simulated operation involving flooding, and what we did there was to deploy a bunch of IoT sensors that could provide them with added information about what was going on in the city so that they can plan their operations better. So we used, of course, the sensors had to be simulated because there were no real flooding going on, but we had flood sensors, power grid sensors, structural sensors that would look at things like bridges to see if they were safe to pass on, street cameras with various kinds of analytics, and also things like UAVs that could be augmented with other kinds of sensors. So this was an example of integrating IoT capabilities into MDO. Okay, so what are some concerns and challenges related to IoT? So one big aspect is privacy and leakage of information, right? So we talked about this with the example of Fitbit revealing the location of a military base. But in general, I think this is a big concern that people need to be worried about in terms of when they deploy IoT devices, who is getting my information. I have to say here that in Europe, they have a set of rules called the GDPR, which is a lot more strict in terms of what information can be collected and what can the companies do with that information. We don't have that here in the US. So if you ever go to Europe and you pull up a web page like CNN.com that you always pull up here, all of a sudden there you get this big dialogue saying, what can we do with your cookies? Well, somehow we don't seem to get that dialogue here because there's no rule that says you cannot collect and use that information here. But the GDPR rules in Europe say you have to indicate to the customer what information is being collected, what it will be used for, who will this information be shared with, and then you can decide to either opt in or opt out. So that's something to keep in mind. So of course there are lots of security challenges with respect to IoT devices, because when was the last time you updated your laptop with the latest security patches, right? There are times when you don't update it even though it tells you need to update. And when you bring in IoT devices, now we are taking, instead of one laptop, we have 50 devices in our home. Are you going to go through the process of manually making sure every one of these updated? Probably not. So that increases the number of vulnerabilities. And there's been examples of websites where you can go and find out all these Chinese cameras that have been deployed in homes where they have not reset the default password. And now you can access them through the internet and get on that camera because, well, the password was never changed by the person who deployed the cameras. So you have to be careful about making it secure. There are obviously issues like bandwidth and capacity limitations as you start adding more and more sensors into your home environment, or in general, it grows. Supply chain is a huge problem because a lot of these components are being typically manufactured in China or sometimes in Taiwan. And during COVID, we saw an example where if supply chain is restricted, that causes a huge problem in terms of other components and their availability in general. So this is something to pay attention to. And then in general, I think complexity is a big issue. So the fact that, and I have a quote here from a computer science researcher, Leslie Lamport, who basically said, a distributed system, and I'll paraphrase this to IoT, an IoT system is something that doesn't work because something I never heard of somewhere else is not working at the moment, right? Because there are all these dependencies on everything that needs to be in place to work. An IoT device that you carry around a lot with you is a cell phone, right? And something that you should think about is the number of different sensors that a cell phone has. A modern cell phone has over a dozen sensors that track all kinds of things, light, accelerometer, barometric pressure, things like biometric sensors, cameras, GPS. And it's not just that these individual sensors, they might seem innocuous, but the problem is what you can learn about somebody's behavior by putting that information together, right? So you can know exactly where a person has been for their entire life if you have a cell phone on you. And by the way, you can go get your own data. So Google, for example, will tell you, you can go to Google and say, I want to download all my data. And you can find out everything that they've collected about you. They know everywhere you've been, anytime you have a phone on you. And so you have to think about, what information is being collected, and the fact that integrating this information can reveal a lot about your behavior. And this is why you get customized advertisements, right? And that's what they want to do. They have to make money somehow, so they sell advertising, learning about what you like and dislike. Also, applications on your phone can leak information, so that's something else to be careful about. And then we talked a little bit about crowdsourcing, right, where the notion is that other people can get information from your devices and then use that to put things together. So here's a funny example of a security lapse with cell phones. So, okay, before I start this, I'm sure a lot of you have used Google Maps to get from point A to point B, right? And it tells you if a road is crowded, and it tells you, go this other route. How does Google Maps know that? Well, it looks at how many phones or how many devices are in this area or in this route, and how quickly they're moving. So this researcher, Simon, basically made a hack where he took a bunch of cell phones, and you'll see this, I won't describe it. He put them in a little cart, right? And he started dragging this cart down this road at a very slow pace. Now, if you're driving and there's no traffic on this road, the phone would normally be moving a lot quicker than in a cart that he's dragging. And he had enough phones in there to override the few vehicles that are driving by that had phones that were moving faster, right? So what does Google do? Basically, it says, oh, there must be a traffic jam in this area. So you can see on Google Maps, the live view, that the road turns red because, well, a bunch of cell phones are moving very slowly along this road, right? So these are examples of, in this case, it's not an adversary, but this is an example of how an adversary can take advantage of the system and provide false information by manipulating the data gathering that's happening from these devices. So, all right, I want to leave a few minutes for questions, so I'll just conclude with this. So where do we go from here? IoT will continue to proliferate. I don't think there's any way to prevent that, because we all enjoy the benefits that it brings to us, right? But one thing that is useful to think about is who's benefiting from this proliferation. So every one of these large IoT platforms, the first thing they do is they collect data about you, right? And you have to think about, is that okay? Do I care? Is it worth it? Is the benefit I'm getting from the convenience of using IoT worth that reduction in privacy? So that's up to you. And if you really care about it, you can actually go turn these things off, but you have to figure out how to do it, and you have to do it yourself. Scalability is a challenge for computer scientists, especially if you really get to the number of devices that they think. So if you scale IoT out all the way, right? So every light bulb in this room will be an IoT device. Every chair will be an IoT device that's measuring who's sitting on it. Every chair will measure how much wear and tear it has. How many times has somebody sat on this chair and gotten up? So if it's above a certain threshold, the chair needs to be replaced. Every light switch, obviously, every floor tile, everything would be an IoT device. So in this room alone, we would have probably 1,000 IoT devices. Now scale that out to buildings and to cities and to the entire planet, and you can see the scalability problem that we have. So this is something that really needs to be tackled, but that's a problem for the computer scientists. Of course, AI and machine learning can benefit a lot from a lot of data, and IoT devices generate a lot of data. So that can be used for good, or it can be used for bad. So we talked about the example of, well, something could monitor your normal usage pattern, and if it's abnormal, maybe there's something wrong with you health-wise, and you could raise an alert. But you can also use that for monitoring the fact that, oh, this person likes to go to McDonald's every Friday and buy something, and maybe I want to target some advertising to that person, right? So another interesting question is, will IoT make us lazy? I'm not going to answer that, but I'll let you all think about whether it does make you lazy or not. To sit on the couch and hit a button or say, Alexa, turn on the light, versus getting up and going to the light switch and turning it on. And then another question is, as these systems get more and more complex, an interesting thing to ask is, will we not understand what is happening? Will you start observing things happening in the real world, and you don't really know why, because a bunch of things are talking behind the scenes, like the cartoons say, and then you don't know, you don't understand the behavior, so you get frustrated with it, you just turn it off, right? So that could be another challenge. So I know I am almost actually an hour, I think, so I'm going to stop here. I don't know if we have some time for questions. Michelle, do we have time?
Yes, we have time.
All right.
Thank you, Gilliam. Thank you for a remarkable lecture.
Thank you.
Stimulating. Smart cars. If a smart car device breaks, if a resistor or capacitor or transistor breaks, does the instrument send misinformation, which could be a disaster, or does it just shut down?
So I think that depends on how the system is designed, and obviously in a domain like automobiles, you would design it with a lot of redundancy so that if one component fails, you have another sensor that could potentially detect that something has failed and account for that. And of course, there are certification bodies that look at things like automation in vehicles, aircraft for that matter, and make sure that they have rigorous safety standards so that things don't happen like that. But yes, I agree that some cases are mission. If your Fitbit misbehaves, it doesn't matter so much. If your car misbehaves and decides to hit a pedestrian, that's a problem, right? So yes, and that has happened, by the way, in some tests that they've been doing with driverless vehicles. Yeah, yeah. Yes, behind.
Thank you. Are they tracking jobs being replaced by the machines and how that's affecting community and particularly our young people?
This is a very philosophical question that I'm not sure I'm equipped to answer. But I think the idea is that these are doing menial things that people don't want to do, right? So that people can do more meaningful things. At least that's the hope. So but it's a philosophical answer. Question. I don't really have a definitive answer for you. It's certainly a discussion. My wife and I have this discussion all the time about how automation is causing people to lose jobs. And one argument is, well, but the automation is replacing a human from doing something menial, so the human can do something better or something different. But yes, it might be true that in the short term, that human did lose a job and has to retrain to do something else. But I don't have a definitive answer to that question.
So I know in the past, like military and government efforts have created technology that now like we use today. Do you think that any of the technology that you showed us or that you're working with could one day be commercialized, like this stuff in the video?
Yes, so actually this is a very interesting trend where I talked earlier about numbers, right? So if you have seen a military communication radio, it typically costs $40,000. It's huge, requires a big battery, and it does probably 1/100th of the capacity of your cell phone. It has some features that cell phones don't have, like robustness to the enemy jamming you and so on. But in general, your cell phone is a lot more capable device than the radio that was developed, custom built for the military. And in fact, for this reason, the military is seriously looking into 5G and 6G technologies and how they can use technology coming out of the civilian sector. And it's because Samsung or whoever can build a phone with this capability, because they're going to sell billions of them. And the military cannot do that. It's just a numbers game. So yes, a lot of these IoT capabilities and the fact that they've been miniaturized to the point where they have been because there's been so much money poured into it, definitely helps the military use, yes. Uh-oh. That's my daughter who wants to ask a question. Should I be afraid?
Screener. Hey.
Go ahead, Olivia.
Where we are right now in the process of making cars, is there a certain date that we would be able to have hover cars?
Have what cars?
Hover cars.
Oh, well, there was an example of a taxi that is a hovercraft that was built recently. I think it was flown in China somewhere. So, not too far in the future, I guess.
Could you comment on any possible health risk of the electromagnetic radiation from all these devices?
Yes, so this is certainly a concern. In fact, some of you may have seen that now it's possible to harvest radio frequency energy, like harvest Wi-Fi energy in order to power certain devices. And there has always been a concern that the RF radiation is potentially bad, but the level of radiation that is coming from IoT devices is very small compared to something like an FM transmitter, a radio station that is putting out a lot more power that even if you don't use the radio, your body is getting it. So I think and I'm not an expert here in terms of health, but I think the risk from IoT devices and the radiation they generate at their power levels is very small.